All right, hey guys, here's a video of me going through the actual test, just to help you review at home tonight. So looking here at standard 1, we're looking at solving an inequality. First of all, solving an inequality is the same as solving an equation. So you're still just trying to get that variable alone. But make sure you keep your inequality symbol. I saw a lot of people losing their inequality symbol, flipping it around, or changing it to something different. So I'm going to get rid of my constant first. I'm going to subtract 14 from both sides. 3m is greater than or equal to 18. And then I'm going to divide both sides by 3 because that will make this 1m, which is what I'm interested in, is greater than or equal to 6. My line graph should have 3 numbers on it. It should have my boundary point, which is 6, where my m is greater than or less than or greater than or equal to or less than or equal to. I'm not interested in this number up here. I want the solution. On either side, I need to have a lower number and a higher number so that we know where where up is and where down is, where the bigger numbers are and the smaller numbers. In this case, I'm going to put a filled-in circle because it could be equal to 6. And then I'm going to put it out to the right because m is greater than 6. So I'm showing the solutions here. So this is that m could be that number, or it could be all this line going this way and up. All right, coming down to b, same thing here. When we combine like terms, the sign in front of the term is important. So if it's minus 2x, that's like a negative 2x. When I go to combine it with 4x, I'm not going to add them. I'm going to subtract it. So 4x minus 2x is 2x. I can now move down and subtract 16 from both sides. That'll give me 2x is less than, and this is 28, I hope. That feels pretty right. And then I'm going to divide both sides by 2. So x is less than 14. Again, start with 14 in the middle. It's an open circle on 14, and it is less than. So it's going to go to the left. Okay, the word problem here. This got a few of us. That's okay. I would like to have at least 18 guitars in my house. At least means I would be happy with 18 or more. I currently have 3 guitars. Write an inequality to show how many I want to have. So what I want to have, that's my x. That's the thing I'm trying to find out. I currently have 3. So if I have 3 and I want to have x, the number of total guitars is going to be x plus 3. Because this is what I want. This really should maybe say want to buy. But to be fair, I want to buy x more. I have 3. And I want this to be what relative to 18? Well, I want it to be at least 18. So I could be greater than 18, or it could be equal to 18. Again, now you're just going to solve this like a regular inequality. So I'm going to subtract 3 from both sides. That gives me x is greater than or equal to 15. I was surprised actually on your tests. I saw more people reverse this number line than I expected. It was like they would graph these ones fine, and then when they got to the word problem, they would switch it around. So if x is greater than or equal to 15, it could be equal, so I fill it in. But it's greater than, so I want numbers 15 or above. All right, down to standard 2. You guys did a pretty good job of writing the original expression here, which is something that I may have forgotten to do on the practice test video. I have, for mat A, I have 3 x's, 1 negative x, and then I have 1, 2, 3, 4, 5 units, and 1 negative 1. For mat B, and I kind of didn't leave myself enough room here, I had 3 x's, a negative x, 2 positives, and 2 negatives. So remember, this is not an equation here. We're just comparing these two mats. So we're not going to divide anything. These aren't actually equal. But we know that we can take away 0 pairs, because those are just 0 anyways. And we can remove balanced sets, because if two things are equal to each other, and we take away the same amount from both of them, they'll still be equal to each other. So in this case, I'm going to do 0 pairs on this side and this side. That leaves me with 2x and 2x over here. Oh, should have put a plus there. Now I'm going to do 0 pairs with my units. So now on this side I have 2x plus 4, and on this side I just have 2x. And actually a lot of you told me at this point that you could already tell that mat A was greater. But if you wanted to, you could take away balanced sets of 2x and 2x to show that 4 and 0, and 4 is definitely greater than 0. So mat A is greater than mat B. Flipping over to the back here, solving the equations. Do not forget to check your solution. Some of you didn't get credit on this just because you didn't check your solution. You'll do great on the retake because now you know that. So for letter A, deal with the constant first, so the thing that doesn't have the variable. So subtract 5 from both sides. That gives me 3x is equal to, is equal to 20. Divide both sides by 3 here. X equals, yes, this is 6 2/3 or 6.6 repeater. I'm going to leave it as 20 over 3, and I'll show you why. When you go to plug it back in to check your solution, this is actually going to be easier because 3 times 20 over 3 simplifies nicely. If I'm multiplying by 3 and dividing by 3, these are just going to cancel out and become 1. So now I can see that it's just 20 plus 5, and that's 25. Moving on to B here. 3x minus 2x gives me just x. So x minus 16 equals 11. I'm going to add 16 to both sides. And x equals 27. Again, let's go check our solution here. 3 times 27 minus 16 minus 2 times 27 equals 11. Sorry that there's not a lot of space on this test. I apologize. 3 times 27, I have to do it in my head right now. So 3 times 20 is 60. 3 times 7 is 21. Together, that's 81. And 2 times 27 is 54. I sure hope I'm doing that right. 81 minus 16 is 65. And I can see that 65 minus 54 is 11. So I'm good there. C, I'm going to draw a line like many of you did to kind of block this out. Sorry for how messy this looks. Distribute first. So 6 times x, 6 times 2. That's going to be 6x minus 12 equals 72. Now you're solving it just like you did with A. Add 12 to both sides. That's 6x equals 84. And then divide both sides by 6. So x equals, 6 goes into 84 14 times. I'm going to go check my work here. So 6, put a 14 in there for the 2. And that'll be 6 times 12 equals 72, which is true. All right, last one. Again, I know it looks messy, but start with the distributive property. 3 times 2x and 3 times 6. So that's, I'm sorry, I got to do this line here. This is confusing. This is 4x minus 12 equals 6x from 3 times 2 minus 18, 3 times 6. I'm going to subtract 4x from both sides. That leaves me with negative 12 equals 2x minus 18. I will then add 18 to both sides, giving me 2. Whoop, sorry for the jump there. My iPad ran out of memory. So I added 18 to both sides. That gave me positive 6 and 2x. Careful here. Negative 12 plus 18 is positive 6. I saw that mistake a lot. Divide both sides by 2. And x equals 3. Again, let's check our work. So 4 times 3 minus 12 equals 3 times 2 times 3 minus 6. I'm just plugging in my answer up here. We want to see if they're equal. So 12 minus 12 equals 3 times 6 minus 6. This one's cool because it's actually going to be 0 over here and 3 times 0, which is 0 equals 0. So that's fine. Some people were confused by that, but that just means the left is equal to the right, so we have the right answer. All right, last section. Actually pretty pleased with you guys in this last section. This was tough. First of all, the lines here, they're equal. That's where our equation comes from. The top line is equal to the bottom. So x plus 2x plus 8 is equal to 44. Combine like terms. So x plus 2x is 3x plus 8 is 44. Now you're just solving an equation just like you were up here. So subtract 8 from both sides. 3x equals 36 and divide by 3. X equals 12. You didn't have to plug this in, but if you plug this in, that'd be 12 plus 24 would be 36 plus 8 is 44. And on to B. B was tough. So my note to most of you who had a hard time with this was to start with zucchini. So if zucchini is my x, it says I have twice as many cucumbers as zucchini. So if zucchini is x, cucumbers will be twice that, 2x. Here's where it gets weird. We have 8 more tomatoes than cucumbers. So it's not x plus 8, because that's zucchini. It's 2x plus 8. Take the cucumbers, 2x, add 8. Now I can make an equation out of these. So x plus 2x plus 2x plus 8 needs to equal 43. I'm going to combine like terms here, so that's going to be 5x plus 8 is equal to 43. And I'm going to subtract 8 from both sides. That'll give me 35. Divide by 5. And I got x equals 7. Now, a whole bunch of you stopped there, but it's not enough just to tell me x is 7. I need to know the other vegetables too. So if x was 7, that's zucchini. 2 times 7 would be 14. And 2 times 7 plus 8 would be 22. All right, that's the test. Good luck if you're doing a retake tomorrow or sometime in the future. Make sure you ask questions. Look back over this video. Or actually, even you got to the end of the video means you're doing a lot here. So ask questions. Come and ready to take that retake.